There's nothing else planned.
So my thought was kind of that this week is 4 days, and 2.1 is a nice 4-part thing. So if we move slightly more quickly than the pace of just a lesson a day, Friday, I'm thinking of doing, some mega Jenga with my other classes if they are caught up on their homework. It's like a little, get them brainwashed now, but if you do your homework, it's a good thing, right? So I was thinking if we move slightly more quickly than this, we can do a little math review game giant Jenga thing. Have you ever played Jenga?
Oh, like yard Jenga.
Yeah, make it bigger. Yeah. So probably the size of yard Jenga. Mine's a little bit, because then, yeah, I ask questions. Before you can draw, come up and pull out a block, you have to get a question right. And then there's points based off what blocks you pull out, so it is a point-based competition, but also don't knock over the tower.
But what if you run into the tower?
You lose 10 points.
Oh, what if you accidentally step into it?
You lose 10 points.
What if you're shoved into it?
You lose 10 points. Well, the person that did the shoving probably would lose 10 points. So, question for you. Oh, and I have a present for you.
Ooh, present.
I should probably hole punch it. Ooh, I did hole punch it. Look at that. These are one-sided on purpose. I don't like printing one-sided, but especially for these, we might end up putting these. Let's say those are yours. You want me to go back to the homework thing? I can go back. Jake, were you not done writing down?
Yeah. Oh, wait.
I would rather you guys write down all of these so you've got it. So if you want to work ahead, you can work ahead. And honestly, all you really need to write down is the numbers.
It's just in order, right? It's just 2.1.
Yeah, and still we're doing all of the problems in the review preview. As they get hard and sometimes problems will take 10 or 15 minutes. I'll only assign a couple. That's why Monday said no school. Or just draw arrows. I can tell he is not happy about that option.
Well, I normally draw arrows if it's an extended homework project. If we have to do something, we're told to write it every day.
Yeah, same. Or the ditto marks. Love ditto marks.
What's a ditto? Like the Pokemon?
The 2 tick marks that mean the same thing as before or above. Alright, so on those sheets I just gave you, we, by we I mean you, are going to try to remember as many of the theorems. Now again, we keep saying to be a theorem, it has to be proven and unable to be disproven, right? Because you can actually prove something and it actually stands for a long time, and then somebody comes along and they're like, actually, we have a 7th grader whose nickname is actually. They say, actually, well, that's what his mom told me.
That was me, and still me, but I try to be less me.
I try to be less me. If we can disprove it, it's no longer a theorem. So some theorems have gotten taken out of being a theorem. So before I even show you the prompt, to try to help us remember, gotta love it when kids just leave their crap on my desk. Even when it was my crap, but they borrowed it. What makes 2 triangles congruent? No questions asked.
2 angles.
Side.
Side. All right, first one on your theorem paper. Let's go and write down side. The snake theorem.
There's one that doesn't work this funny, though.
Yeah, we'll get there. Why does side tell us that those 2 triangles must be congruent?
Because how else are you going to organize 3 sides of the same way?
Ooh. Because there is no other way to organize 3 objects. So what you're saying is ABC is the same as ACB?
Is the same as A.
No, actually, that's not what I was. Wait, from a triangle standpoint, yeah.
Why? Why is ABC the same as ACB?
Because there's only 3 sides. So, they have to, each side has to be next to the other 2 sides.
Ooh, there it is. Each side has to be adjacent to the other 2 sides. So really, the order of a triangle, when we say it, it can start anywhere, go any direction, right? We can reorder triangles all day long, so that's why side is one of those that we can use no matter what. If the 3 sides of a triangle are the same, they are congruent. We don't have to read that. So, what do I hear then? We got two sides.
Ooh, this is side angle side.
What do you mean it's side and side?
Hear that side.
Okay.
Yeah, it's side
And
and
then
side.
can't you have
Or angle side, angle.
angle down?
Yeah, it could be either. It could be side angle side or angle side angle.
Or if you found out the hypotenuse angle.
Or angle angle side.
Or Pythagorean
Angle,
theorem,
angle,
and then side, side, side. Or,
Or-
there's already two angles, so you can just calculate the same angle.
Yeah.
Okay.
And then you have angle, angle, angle.
So we
That-
just
that-
listed.
Wait, no,
that-
that one
that
doesn't
is
work.
similar.
Never mind.
Okay, wait,
That's
why?
similar, but
Hold on. Say more, Connor. We'll let you talk now, because I think actually I controlled the first one. It's okay, we just want to take turns. Like, that's totally fine. So, Connor, why doesn't angle, angle, angle work?
Well, because the-
You guys just told me if we have three sides that are the same, they can't be arranged any other way. They, it's going to be the same. So why doesn't it work with angles?
Because
because
then you can do like this.
Well, Connor, you're a ventriloquist.
scaling.
You can scale it. So when we scale triangles, angles don't change, right? So that's an important thing to remember, is that the angles only give us so much power. The sides are really our linchpins here.
What?
Linchpin? The linchpin is it's a thing that if you pull out, like, things come apart. Or, so, like, it's like what
Oh
holds everything
yeah,
together.
those things.
Yeah.
Like, yeah.
It's also called a cotter pin,
Yeah,
Yeah.
that's the thing. That's
often made of brass. So you said here we could do everything except angle, 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 because what do we use angle, angle, angle for?
similar.
Similarity.
Also, we can do angle, side, side, because it just doesn't work.
Why doesn't angle side side work? So let's say we didn't have this 90 degree. I appreciate you bringing that up, and for some reason I just got a headache all of a sudden. Not because of you guys, because you guys are awesome.
Yay.
One of my favorite parts of the day.
You like to be on.
Everything is awesome.
I
So
like
let's say we don't know this. How does an angle side side work? Let's say you were helping a 7th grader of mine, right? Obviously you guys are going to be learning this. But like, so I'm not trying to talk down to you, but we got to review these things, right?
Oh,
So wait, can I come up and draw?
Sure. We know the 28. See, okay, so this is being weird, by the way, when you guys come up. Every so often, the pen stops working for like half a second. So, like, it's not broken permanently. It just every now and then decides not to write for a second. Those things are what we know.
So we don't know this side, right?
Correct.
So then
We don't know anything but what has green arrows.
So then, if we don't know this side, then you can take this side.
Yeah, you can make it.
Oh, there is a pivot that could still make the 28 degrees happen. Ah, so there's two different triangle there's two different triangle arrangements when all we know is angle side side. Connor, do you have your hand up?
never mind.
Yeah, that doesn't keep fixed length unless you lock it. And then if you lock it, I think it won't let you move it. So it's kind of frustrating. I think there is a tool up there that does fixed length. But we'll start to use GeoGebra. If you get bored and you want to look at another app or like math website thing, GeoGebra is pretty sweet.
Yeah, you
Is that like
Yeah.
can
geometry and
make
algebra?
3D graphs on it. and
They
it's so-
think they're clever. Yes, GeoGebra. Geometry and algebra. Alright, so Luis wants to write a statement of the two triangles that are congruent. So he starts with triangle MNP will be congruent to.
Ooh, but,
We said order doesn't matter,
well, it doesn't matter.
except when we write two triangles related to each other, order is critical, right? You will get the question wrong if the triangle is in the wrong order. I'm telling you that now. I'll mark it wrong, and you'll be like, well, you know what I meant. I'm like, that's not what you wrote.
So it'd be congruent to UW.
Yeah, so especially because like all the sides are adjacent to each other, sometimes this is a little bit tricky. So M to, see, I didn't want to write that. M to N is our first side that we're given. So that would relate to, is it U to V or V to U, or U to W or W to U?
U to W.
How do we know?
Because the M has the 6 times 7, so does the U.
No, it could be P to N actually.
So we took the fifth, so the next one's going to be N to P, right?
How could it be P
N
to
to
N?
P.
Never mind. I'm stupid.
So our first one is the length of 15. Headed towards our second one is the length of 12. Right? So we know we need to order our triangle to go the 15 side. Oop, can't go that direction because now I can't get to the 12 side. So we got to go the 15 side to the 12 side. So we would help them out, and we would say the order that you want to write that. U, double U, single U, then double U.
It's a triple U.
Alright. Okay, sequence of, I know you guys know your transformations.
Rotate.
And you could either say rotate about a point in space or rotate about that point and then translate, right? I know you guys know that. I just kind of stopped teaching that, especially because I want to play Jenga on Friday. So, on your own for a second, because we often answer together, dude, just put them in the thing and leave them be. If we got time to be in the class, you can play it. Those are for Math 7. Probability. Take a moment on your own, write down, if these two triangles are congruent, write down the congruent statement. You're always going to need paper in my class.
It's all random piece of paper.
I know.
Probably the notes paper you've been using.
Yeah, this.
Yeah, sure. That looks perfect.
Do you have a math notebook?
Yeah.
If you'd like one, I have plenty of spare notebooks.
Yeah, I even wrote our triangle check thingamajig in it.
Triangle check thing.
Check mark 1, check mark 2. Now I'm curious if the three of you come up with the three different statements without talking with each other.
That'd be great.
That'd be kind of funny.
It's a 1 in 9 chance, but
Wait, should we just write the statements, or do we need to say like why?
well, you should at least know in your head because you have to make the decision before you write it, right? So I will, you guys, we're still at the beginning of the year, so let's like make a deal or whatever you want to say. I will promise to keep what we have to write to a minimum if you promise to ask questions and or write things down for what you need to. Is that like, can we agree on that? Because there's only 3 of us in here. I won't force you to write things that are silly if you ask questions and write when you need to. You know what I mean? So we do need to practice getting this order right. One of the orders you could have had, are they congruent?
Yeah.
Why? Side, angle, side. Now wait, did we write this one down in our, we didn't write any down in our paper yet, did we? Grab your theorem, grab organizer.
I mean, I wrote them down. I didn't.
Oh, you did side, stop. Side, angle, side does create triangle congruence. What would be our if-then statement? It feels almost silly to like say it out.
If two angles have
Two triangles.
Have two congruent sides with the congruent angle that connects them.
What do we call that? There's a good name for it.
Buy something?
If this is the one side we're looking at, and that's the one
Legs, those are
Included angle.
included angle. We gotta be inclusive here. We gotta include the angle. So the included angle. So whatever you want to write to remember this, two congruent sides with the included angles congruent. Because that's how we're sure that order is the same, even if we orient the triangles differently. Two congruent sides, included angle. This also is Hinge Theorem. Because, keep your eyes back up here when you get a moment. This is Hinge Theorem because I have my door and my door frame as fixed lengths, right? Let's call this my door and this my door frame. And that door is way too big for that door frame. And if this is also my door and my frame, the angle is how open the door is, right? So I'm hitting this other wall up here, but like this is Hinge Theorem. Because what Hinge Theorem tells us is, well, if this angle relates to that side, and this angle relates to that side, and they're both opened up the same amount, and they're opening the same thing, right, sizes of the other side, this is Hinge Theorem also. On your own, decide.
We didn't check to see if we had 3 different ones.
Oh, yeah, sorry. I get in a hurry. Connor, give me yours.
RLN is congruent to CAB.
RLN. We should technically put the triangle in front of it.
Oh, yeah.
Because otherwise we might just be talking about an angle.
I did put that.
So you said RLN.
CAB.
I was really catching myself, like having not written it. Jake, give me yours.
I have
Sorry, you guys-
RNL is congruent to CDA.
Ooh, RNL. It's working so far in the auction. I could just lie and change her answer right now if she wants. CBA. Okay. Okay.
Triangle NLR. Triangle
To what?
Triangle
Oh, triangle symbol.
He's a composer. Well, it's an A chapter, then he's a composer.
Yeah, just
Good
add that
job.
fourth point.
Do we all agree with all these?
I don't know if I agree that this was all our answers.
Well, I wrote that.
No.
Yeah, she probably wrote all 3. So here's the deal. There's not one right answer for triangle congruence. We often default to alphabetical order. So A, B, and C have an alphabetical order. R, L, and N a little bit more awkward. So we often default to alphabetical order.
Of which one?
Well, do we even have the A, B, C up there? No, so if I write A, B, C,
Oh, yeah, there's.
there are more of these guys.
So it's not actually that unlikely that it's.
So, like we established earlier in class, ABC is the same thing as BAC, is the same thing as CBA, is the same thing as CAB, because we said the second 2 points don't really matter which order they come in. So guys, what I'm trying to get us to do, I'm hoping that Jake is still with us, is say this is the best way, and it lets us all speak more of a common language. Right, so if we start this triangle congruent statement by saying, triangle ABC, then it tells us the order to do our second one, which isn't as nice of letters. So if I go A, B, C, I'm going 1 tick mark to no tick mark. So we would be 1 tick mark to no tick mark, L, N, R. So this is the difference
So it
between
is alphabetical.
this is the difference between right and wrong, or better or not so good. Right? This is not right versus wrong. This is just better so we can all speak a common language. Guys, there's actually 9. There are 9 congruent statements. So if you're in a room with mathematicians, it makes more sense to agree on which one's the best one to use. They're all possible options.
Especially
Do you have
if you're
questions?
saying it a lot.
Who what?
Especially if you're going to be like talking about it.
Absolutely. Yeah, you need some common language. So on your own, take a moment. Are these congruent? If not, why? Oh, but wait, there's one.
If it is, we
If
have
it
to
is,
move on.
write the congruent statement in the best way. If it is congruent, write the congruent statement in the best way. At the end of class, I'm going to ask that, especially the groups that you guys are at, we spread the desks apart, so we're doing math makeups in here.
Oh, math test.
Math.
I was like, what do you mean math test?
Math sounds too much like math.
Math is almost up though. but we don't know.
Then we don't know. We cannot assume, because you know what that does.
Makes an ass out of me.
Whoa! He went and said it.
Don't go and say the poopy
He went and
first.
said it.
Are you
It's like
on?
recorded on YouTube and everything. He went and said it.
Like, the head was because they were not allowed to curse. Because we're not allowed to curse, it offends the sensibilities of ordinary people. I read the law. All the factors.
I don't really care about it. I have to care about it because I'm in a public school. Gotten my mom to swear like twice in our life.
In your life?
Once was when my sister spilled nail polish on the new carpet in the living room. She really quickly said the D. She was like, "Dang it, Abby!" It wasn't dang it. And I was like, "Mom's mad! Mom's real mad! Mom doesn't swear!" Is A congruent?
Yeah.
Why?
Sass.
Sass. Not sus, it's sass. Oh, come on, just write. It's getting more and more frustrating. So, side angle side, if we go the best way possible, we're going to say triangle. Triangle what? FED. And guys, now we can way more easily check, did we all put this in the same order? Did we all use FED? As opposed to trying to think through the 9 different orders of options.
Oh, I just said sass.
Well, then we need to write the congruence. Okay, this is what I more often than not have to count wrong on tests. Because kids just like, you write down both triangles, but you accidentally switch up the order. Which matters. Like as we're writing code and things like that, it matters. B, are we congruent?
What do you all know?
On B? But I see 2 sides at an angle.
But it's not the same because,
The angle moved.
yeah.
So here my angle's included. Here my angle's not included. So this is why when we wrote our theorem, we have to have it written not just as 2 congruent sides and an angle, 2 congruent sides and the included angle.
It's sass and ass. Or it's
This
sass.
one's sus because it's side unincluded.
Like there's an E and an F.
Yeah, I said, okay, there's more. Sorry, I just didn't show them yet. Yeah, you gotta keep you on your toes.
How
Now-
do you do?
Now, you asked something earlier, and I wonder if it had to do with C. What can we figure out in C?
You can do alternate interior angles because of the parallel.
Ooh, because the parallel sides, I can do alternate interior. So angle Y would relate to angle N
In vertical angle.
and vertical angles.
Oh, I did M is congruent to C.
Yeah.
And we can do that. I guess I might as well say purple.
Because is that also alternate?
Yeah.
Yep, also alternate interior. So now are we congruent?
Yeah.
Angle, 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 one of the best ones.
Angle, 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 side.
Or we could do.
Wait, actually,
Angle doesn't work.
Angle, similar.
Yeah, good catch. It's one of the best ones for similarity, and actually one of the only ones for similarity, unless we're checking scale factor. Angle side angle works for similarity if you check scale factor, but if you have angle, angle, you have all 3.
How to do angle, side,
Yeah, we can't use this. We have all 3 angles. This is a trap door. You can't use angle, angle, angle for congruence. Guys, I would fall into that all the time because you get excited. Then you're like, oh, I got 2 angles, I got 3 angles, boom. Don't use it. We gotta have a side. So angle, side, angle. What's our order?
Oh, I have to write them all down.
what if you use congruent to X and F?
Yeah, X, Y, Z is the easy one to make them alphabetical. So use that one first.
Yeah,
X and ooh, sorry, Frank.
no.
Do I have any lengths aside from the tick marks?
I mean, AD is congruent to AD because of reflexive operator.
Ooh, reflexive property. Might as well mark that.
Well, then, there's nothing else.
And then if you use that
Well,
Pythagorean
we
theorem.
kind of know
Well,
this.
how do we know that DC how do we know that CD is?
Lines that appear to be straight are straight.
Oh.
That is a rule, like, in the book. Like, we're publishing pictures of things, lines that appear to be straight are straight. So we know a straight line is 180 degrees. So,
So don't we know that C and B are congruent because of like a right triangle?
Well,
C and B are, what do you mean?
Oh,
Angles C and B
yeah.
they have to be the same, right?
Why?
because of the isosceles thing, like, I don't know what it's
Just like,
called.
just reverse the fact.
No.
Yeah, because it's an isosceles triangle.
Yeah, so then the opposite angles are congruent.
How?
No,
It's an
how do
isosceles.
you explain it?
How do you know
Forget
it's an
about
isosceles
this.
triangle, though?
Forget about this.
Oh,
Triangle ABC.
So this is actually, this we'll draw, on its own is an isosceles triangle, telling us that these gotta be the same. Now also, now that we have two sides because we used reflexive, cough cough, Hinge theorem,
So wait, oh, so it's perpendicular, that means it bisects it, right? If it's coming out of the central angle, then it's perpendicular.
well now, yeah, because we know it's isosceles, and we know it's heading at a 90 degrees, yeah, now we can make that reason, but I don't even know that we
And
need
it bisects
to.
the angle and the line.
Well,
So
we
now we
have
know all the
angle
sides
and
and all the angles.
Like, we already have.
What does knowing two angles tell me?
The third angle.
That I know three angles. What does knowing three angles tell me?
That you know it's similar.
That I know they're similar. What else do I need?
A side.
Well, we have.
And
we already
side.
have side angle side.
Yeah, guys, so as soon as we have two angles, if we got side, it's got to be the included side, right? So, have we written down side angle side yet? Or, sorry, angle side angle is what I meant to say. Even not knowing these, because we're having this debate of like, are we allowed to say this? We knew the base angles because of isosceles, right? For sure. We know reflexive, and we were told, well, we could just really, well, no, we don't know these sides.
Well, we know that they're congruent because it bisects it.
Yeah, if we remember that theorem. So you're right. I'm not saying you're wrong, but we don't even need these side lengths because as soon as we know these base angles, and we already were given these, we know the third angle, and now we got side angle side.
Well, we already had angle side.
We know all the angles and all the sides.
Ooh, does angle side work?
I think so.
Yeah. That's the one I use.
Write it down and put it on a theorem paper. If you don't have it on your theorem paper yet, angle side.
That one does work.
I don't know how.
So wait, does side angle work?
Well,
Yeah, because it's the same.
Oh, it's the same as angle side.
Yeah.
Does angle side angle work?
Yeah.
yeah.
So could we make like a blanket? Like,
If you have two angles and a side or two sides and an angle.
will that always work?
No, because
Or no. If you have two angles and a side.
Okay, I'm thinking about this.
Or three sides.
So wait, crap, I can't do ABC. Crap, they took away my chance at ABC.
no, you have
Might as
to
well do ABD. Right, so we do ABD, congruent to,
I did not do ABD.
ACD, right? Still alphabetical order helps us out. Think about these two. I'm going to show some Destron for a minute.
I don't like the
I'm
alphabet.
thinking about something. I almost have it, but
You almost have what? What is there to almost have?
I almost have like the theorem that I can prove that Y and G are congruent.
Y and G? Well,
In-
have you already done
In
so?
F,
Yeah, and that one.
Oh,
I'm trying to think because. Oh wait, hold on.
Good thing we wrote down the definitions of shapes, right? Back in chapter
Yeah.
1. We had a
I
nice
don't
good
know
list.
exactly how to phrase it, but I know that.
Hey. I know the other pen's up there, but I need to move desks.
This bisects that.
You like bisecting, don't you? Why did you just... It looks like someone ripped his bloody claw.
So wait, you know it's
I forget
an
how-
angle bisector, right? That's given to you because those angles are congruent. Should we like to E real quick? What's the case with E?
So wait.
Vertical or alternate interior angle.
We have angle, but that doesn't do it.
No, but we also have.
But we also have a side.
Yeah.
Oh yeah, we do.
As opposed to the left.
Now wait a minute.
What?
That sure doesn't look right.
How does that not look good?
What do you mean, how does that not look right? Those angles don't look the same.
We can't go by how it looks.
But
You're not supposed to go by how it looks, right?
what angles don't look the same?
I see where you're coming from.
So when we use alternate interior angle theorem, let's go back and clarify.
Oh wait, we can't.
Hold on. Let everyone else make the realization too. Hold on. When we use alternate interior angles, we are alternate the transversal and interior the parallel lines, right? So Jake, now go ahead and say what you realized.
Well, you can't do that
Why?
because this is not. These are not parallel.
Are we allowed to, the marks you left up there right now, are we allowed to say those?
Yeah, because these are parallel. This is transversal.
Yeah, so EF and HG, those are parallel, and those angles that Jake has marked, those are interior of our parallel and alternate the transversal. But
Yeah, so it's angle angle side.
sweet, does that work?
Yeah.
Are we sure?
Angle,
Those are the
side.
same?
Angle angle side. Wait, but they shouldn't be the same.
If you just like,
But it works, but they shouldn't be the same.
if you ignore these, it's parallel lines with a transversal, and then these are alternate interior.
Are those congruent?
They
Do we
shouldn't
all
be
agree?
congruent.
Like, do we all think they're congruent, or is anyone like torn?
I think they're congruent, but they shouldn't be congruent.
Because like, I'm torn.
Wait, oh!
I just can't quite see it.
Oh! It didn't tell us that those two lines are parallel, but I think they actually are.
Yeah, it did.
parallel.
That's
No, it told us those two lines are parallel. I mean the other two lines. That would be how it would work. It would only work if those other two lines were actually parallel.
That's not true.
That lied to us. How is that not
That's
true?
not true. Because, well, just get rid of like this.
Okay, so Jake, we've proven that the triangles are congruent, right?
Yeah.
So then all the angles are congruent to the corresponding angles, right?
Yeah. Hold on.
So you can draw that, and all the sides are congruent to the corresponding side.
Correct. So I think you might be right. I think these are parallel.
So those, because of the reverse of the vertical angle theorem, those two lines have the converse. That's what's
Not vertical, but you're right.
Or yeah, alternate interior.
So yeah, this has to be congruent to this.
I like how you're not using the pen and you're using the fattest setting of ink.
That has to be congruent to that.
Wait, oh, what?
Wait, why?
Those are on the same
Oh
triangle.
yeah. I messed up.
So, if parallel lines with a transversal, then alternate interior angles are congruent. Right? We all agree on that. That's one we love. And we're allowed to do it there with that top angle F and the bottom of angle H. It just did the funky little glitch thing. And then, if two angles of triangles are congruent, then the third angles are congruent, But we are not figuring that out based off parallel lines.
So this is a kite, that means.
So then, if three angles of or two angles, because we know two angles, then we know three angles, and a side, guys, these are congruent. You guys are right. I appreciate you continually standing your ground. And the converse of alternate interior makes E, H, and F, G parallel. Those lines are parallel.
Even though they don't look.
So remember what I said the rule is lines that look straight are straight. But lines that look skew are not necessarily skew. Lines that look parallel, lines that look parallel, not necessarily parallel, right? Unless it's marked. So do not trust when things look skew or look parallel. Do the math.
What did that board do?
Stand your ground and do the math.
I'm so happy.
I don't like standard ground though.
So F, we have one side, one angle.
Well, reflex.
We have two sides.
Ooh, reflexive, we have two sides.
Okay, and then I don't know how, but I'm pretty sure LY and LG are congruent.
You don't know how.
I forget the theorem.
That's not a very mathematical statement.
Yeah, I realize that.
Alright, reflexive. I like to mark reflexive so my brain thinks about it. Does our line LC bisecting angle L mean that we bisect angle C?
No.
Wait, can't you? Wait, no.
Yeah, I think it does.
Because we don't know.
What? No.
We don't know the measure of LY.
If you're going to say I think it does, I'm going to follow it up with why. Or how. So you have to be able to defend. If you're going to assert something, you got to be able to defend it.
Oh. Oh no, never mind. That's not how angles work.
So, wait.
I got nothing. Remember when you said things were easy? Took like 2 weeks to get here, didn't it? Now we're just scratching our head.
I'm thinking of something, but I'm not sure if that's gonna help.
I really just want the G to be a U, so we can call this Lucy. But I'll get that thought out of my head. That's literally the thought in my head. Do you guys want to tell you, or do you want to leave it hanging?
I don't care.
It seems like we should know something else.
But do we?
What? I'm not sure if this will help.
What? Tell us anyway.
What if you made a line that you're making these two things like sauces? I don't know if that's gonna help.
But we don't know if those two are perpendicular to the thing.
Oh yeah.
Oh.
We don't know if the line would be.
Question.
So
We would know that if we knew that C
Could-
LCY and LC.
Could everything, remember when we talk about and can't be disproven? If we can find a way to disprove it, then we know we can't prove it. Could everything written up here stay true? And I don't even know how to ask this. I'm going to ask a bad question, and I don't want to, because as soon as I ask bad questions, you can't take them back. Could everything we see up there be true, and the triangles not be congruent? So we will pick this up tomorrow. Since what we know is side-side angle, ask yourself, can we keep what they've shown us and make non-congruent triangles? You can disconnect them if you want. All you know is that two of the sides have to be the same. The non-included angle, we'll pick this up tomorrow.
well, if we figured
I
out,
don't know. Maybe
if we figured out why ask doesn't work.
And then is there any,
That word.
Then related question trying to talk over Jake. Is there any situation where ASS does work? You said it doesn't work, but is there any situation? Because this, we just said doesn't work. Well, probably doesn't work. We think it doesn't work because it is the bad word. I want to know, is there any special situation when it does? All right, have a wonderful day, guys. It is 12:17. Yeah, we do it in this class right now. Thank you.
It's noon. But it's not noon.